So in this question we're told that a hexagon has interior angles of 120 degrees, and by interior angles it just means this angle in here. So each of these angles are going to be identical all the way around the hexagon, and they're all going to be 120. And we're also told the side lengths are 10 centimeters. So again, that's going to apply to every one of these sides here. And so there's going to go all the way around. And we're basically asked what the distances AC and AD are. So we just need to find the length of these distances. And I'm actually just going to start off by first of all drawing this. And so I've just drawn the length AC as a blue dotted line and the length AD as a green dotted line. And now we kind of got to start working out these distances. So I'm just going to kind of put in all the information we have here. So we've got this 10 centimeters on the top, again 120 on the top left here for the angle, and then also 10 centimeters for this side AB over on the left as well. And so you can see straight away that we actually do have all the information we need to work out the value of AC, because we've got an angle in here in the middle and we've got two sides, either side of this angle. So we've got 10 centimeters on one side and 10 centimeters on the other side. However, we can even make it simple for ourselves, because if we look at these two sides, we know that they're both 10, and that means that this is an isosceles triangle. So isosceles triangle is any triangle with two side lengths and two angles that are both equal in the triangle. And so we can actually work out these based on that fact. So because the angle at the top is 120, if we just label each of these little angles in here x, because we know that these are going to be the same value, given again that this is an isosceles triangle. What this means is that if we have 180 degrees in every triangle, which we know that we do, we can say that 120 plus 2x is equal to 180, because that accounts for all of these three angles. And so therefore 2x is going to be 180 minus 120, which is going to be 60, and therefore x is going to be 30. So that is going to be 30 degrees. So now we know all the angles in this kind of little triangle here. And so that's kind of step one, if you like. We've just found some of our angles here, and now what we can actually do is use the sine rule to find the value of AC. And so basically if we set up an equation here, we're basically going to have AC over sine 120 is equal to 10 over sine 30. Again, because the side AC is opposite this angle of 120 degrees up in the top. And then we've got, we worked out that the value of each of the angles on the left and right in this kind of triangle involving AC is going to be 30. And so we can just set up this using the sine rule. And this is kind of a version of the sine rule where you have the sides on the top and the angles on the bottom. So we've got A and B on the top here, as you can see, up in blue. And if that looks unfamiliar, that's basically just flipping each of the fractions in the sine rule so you get your sides on top. And the only reason we do that is because it can be a bit easier to rearrange this, because we can see straight away that we can just multiply across here in our equation by sine 120. So we get AC is equal to 10 sine 120 degrees, and that is going to be divided by sine 30 degrees. So we can now work that out. And by just plugging that in, we're going to get that the length of the side AC is going to be 17.32 centimeters. So that is going to be the first one of our sides here to find. And we can actually just write that in as well, because that might be coming in handy here in a second to find the length of AD, so that we know that this is 17.32 centimeters. And so if we look at this triangle here, we need to figure out kind of what other information we have. And I think the most straightforward way to progress here, I'm sure there's a lot of different ways you can approach this, because hexagons, being as symmetrical as they are going to allow you a lot of different ways to approach this. But I think the most straightforward way is going to be to recognize that if the overall value of this angle here in green is 120, then either side of the green dotted line is going to be having a value of 60. Just again dividing this by 2, because you can see that AD sort of bisects this angle. So we know that if the overall angle is 120, then this horizontal line AD is going to be cut in half. And so now that we know that this is going to be 60 degrees, we can actually use a sine rule again to find the value of AD. But I've actually just realized we need to do a little bit more work, so we can't do it quite yet, but we're almost there, because we know that the value of the angle X is 30 degrees, and it's 60 over on this side as well for this kind of overall angle in here in at A, if that makes sense. And so therefore this is also going to be 30 degrees in here, and so this is all kind of based on the symmetries in a hexagon. And then therefore if we've got a 60 and a 30 in this triangle ACD, that means that this angle up at the very top is actually a right angle, so this is going to be 90 degrees. Again, that's kind of it's a little bit hard to see here, but I'm just going to put it in green in here. So this angle in here is 90 degrees, and so now we can actually use our sine rule to find the length of AD. And so if we look at the angle opposite AD is going to be 90 degrees, that's the angle up on the top, roughly at C, and so that is going to be just sine 90 on the bottom of our fraction here for the sine rule. And then on the other side of our sine rule, we want a known side, so we can use our 10 centimeters over here on the right. And then the null angle opposite this side length of 10 centimeters is going to be sine 30, so that is going to be coming from just looking across from our 10 centimeters. So if we kind of draw an arrow here across from 10 centimeters, you can see we've got 30 degrees there at the bottom of this triangle ACD. And so now we've got all the information we need, and we can once again do the same thing we did before when we were finding AC, and just multiply across by sine 90 here. And so we get 10 times sine 90 divided by sine 30, And this is actually a very simple expression, even though it doesn't look like it at first, because the value of sine 90 is 1 and the value of sine 30 is a half, so it's going to be 10 divided by a half, and that is going to basically be the same as doubling it, which is going to give us 20 centimeters. And so that is the side length AD, or the kind of horizontal distance across the middle of our hexagon. And I realize that there's actually a lot going on in our diagram here, so hopefully this all made sense. Basically, we're just using the sine rule to find the length of AC, and then kind of using the angles and once again the sine rule to find the length of AD here. And so that's going to be it for this question.